So these were pretty easy, right? We're looking for the circumference of this shape, and what do we need to find the circumference of the shape?
C equals pi.
Yeah, C equals pi times D. And by the way, you will not have to memorize any formulas when it comes to area because they're generally given to you on every test that you take. So I just want you to know how to use them. Do not memorize them. You don't have to. It would be helpful if you do. Uh, and now this tells me that to find the circumference, I have to get 3.14 times diameter. What is the diameter? 36. So what is the circumference?
113.04.
Thank you. 113.04. If you got this wrong, we have serious problems. So depending on how it goes, we're going to talk about it in a minute. But you should not be getting those wrong because you had the formula and it was very easy to calculate. You just multiplying those two. For the area, what is the formula then?
Area equals pi times r times
Exactly. So we know that pi is 3.14. And what is r?
13. I mean, 36 divided by
36 divided by 2, which is what? Whoa, 18. 18. 36 divided by 2 is 18. You multiply those two and then multiply it by pi, and you get 1071, is it? Oh, 17 what? I don't trust you. 18 times 18 times 3.14. Yeah. 1017.36 centimeters. Are those cubed or, I mean, squared or regular? Why are they regular?
it's squared because it's the area.
Thank you. It's squared because we're talking about the area, the inside, how many squares it could fit inside, right? The other one was the circumference, which is the distance around the edges. Just one distance. Of course it counts. If they got it wrong, just put it wrong. That's it. You're just grading it. All right, for the next one, we're going to use the same formula. Circumference equals pi times diameter. We know pi is 3.14. What is the diameter?
14.
Why is it 14 and not 7?
Because the 7 is the radius.
7 is only the radius, right? And then you need the other half, which is 7 as well. So when you add them up, you get 14. What do you get? 43.96. And these are meters. Are those squared?
No,
Why not?
because it's not the area.
It's not the area circumference, right? It's just the distance. What about the area? Yep. 3.14 times 7 times 7, which is 49, right? So 49 times 3.14, that is 153.86 meters. Are those squared? Absolutely, yes. For this time, I wouldn't take too many points off of that because you got the calculations right. But I just want you to know for the testings, if you don't know which one it is, you're gonna get it wrong. So yes, if you got the right number, but you just did not put the right units of measurement, then count it right for this time only. Does that answer your question? Okay. The next one was easy as well. The first thing that I told you yesterday in the video that we recorded is that when you look at these shapes, the idea is that you want to find formulas that you can use so you can find the area of each of them, right? Because there is no formula to find the area of this thing looking like that. But when you separate it, you end up with a triangle and a semicircle. What is the formula to find the area of a triangle?
Base times height divided by 2.
Yes. And again, you do not need to memorize these things, but it helps. You can always go back to them and see what you need to put in there. So the base we know is 14, right? The height is 10 divided by 2. The area for that will be 140 when you multiply those two. Divided by 2 is 70. 70 meters for the triangle. For the semicircle, we know the area is pi times r times r. But what else do we have to do?
7 times. Yeah, divided by 2.
Divided by 2. Why are we divided by 2 at the end? Because it's only half, right? So 3.14. And somebody says 7 times 7. What do you use 7 times 7? That's the radius. 14 is the diameter. That means 7 is the radius. You're doing like exceptionally well. I like it. So this is the same as the one on top, actually. So I'm going to just divide 153.86 by 2. Oh, dang it. And then I get 76.93 square meters, right? Now what do? You add them, right, with 70. And my total, my final answer is 146.93 meters squared. This is my final answer. It seems like a lot of work, but it's actually just little calculations here and there. For the next one, it's super easy. When you break that shape into two, you end up with a parallelogram on top and a rectangle at the bottom.
That triangle right there, can it be on the other side?
Yes. So basically what she said, that you can grab this thing and put it over here to fill it up, and you end up with the rectangle right here. Now you have two rectangles. In reality, that's the parallelograms.
Could you add the 5.5 to the 4.5?
You could do that, and you have a long distance of what? So you have 4, 9, 10, right? Centimeters. You're actually the first person, the first student that suggested that. Usually we look at the parallelogram, and I was trying to explain why it works. If we move this to that side, we end up with the rectangle, which tells me that's exactly why the formula based on height works with the parallelogram, because you can move them around and shape it into a rectangle. And you should have had two areas, but now that she noticed that you created one whole box, it makes more sense to just combine the two measurements of 5.5 and 4.5, right? Which gives me 10, right? So now all I have to calculate is 20 by 10, which is what? 200. 200 centimeters squared. Excellent job. That's amazing. She needs a clap for that one. Let me hear it. Good. Good, good, good. That was really good. I'm very impressed by it, because I actually none of the kids even thought about it. All right, so let me pause right here, and I want you to record the grade. Okay, so after you draw that line, and you draw a point somewhere in the middle of the line. That's fine. Leave it, put it on the side. Don't worry about it. I want you to grab your little string and put the very end of the string. The very end of the string right where your dot is. So place your finger right where the dot is and hold the end of the string with the other hand. Hold the other end of the string with the other hand. Let me watch what I do, guys. This is probably one of the basic things that you probably have ever done in your entire life, and some of you are confused. Grab the end. I'm showing you the end of the string, right? Look at your index finger. That one. Yep. Well, you're grabbing one with the one hand. That means you only have one index finger free, right? Ah, see, brilliant. So you're going to place the end of the string and your index finger on the dot that you created. Like that. Watch, just like that. With your other hand, the free one, you're going to grab the other end of the string and pull it, but keep it together. I want you to move the string side to side without, let me emphasize, without passing the lines on the side. Let me show you. Imagine this is my string, and I'm moving it side to side, but I cannot go behind the line here or behind the line here. I have to stay here on top the entire time. And some of you have like long ones, some of you have short ones. It doesn't matter. I just want you to get the feel of doing this. This is what create angles. Now, I want you to select a random spot. I'm just going to select this one. It doesn't matter. I want you to select a random spot, and I want you to draw a point right there. Select a random spot, draw a point right there, and trace it. It does not, it has to be on top though. I told you not to go below, right? You cannot go below. It has to be on top. No, it's not. But for this one, just for the exercise, stay on top. Stay on top. Trace the line. Put a dot and then trace the line. Are we all good? All right. Now, looking at that thing right here, well, actually, I want you to draw a point on one end of the line and on the opposite end of the line. So we have a point on the end, in the middle, at the other end, and at the point that you created. I want you to label those points. It'll be this way. The first point is A. The middle point is B. The point you created, wherever it may be, that is C. And the last point is going to be D. It does not matter. It doesn't matter. I'm talking about the points at the very ends of each line, right? And then the point right in the middle. A, B, C, D. Yes. C is wherever you created the point. Where did you create the point? We got it? Is anybody confused where C goes? Thank you. Thank goodness. Okay. I was about to get worried. Now that we're looking at this, can somebody tell me what they know about the angle of the main line? Yes. Not the type of angle, but degrees. Yes. 180. So you need a point in order to find an angle, because a line doesn't really have an angle unless you have a point and then you're comparing, right? So for point B, when you go from here to here, you create a 180-degree angle. That means a straight line has 180-degree angles when you find a point there. So 180-degree angle for that B line, right? For the point B, because it's a big straight line. Now, I'm going to create another angle in blue, and this angle will be composed of A, B, and point C. And this is how you draw it. It almost looks like the less than sign, but this one's flat at the bottom. Angle A, B, and C is in blue. It doesn't matter how yours looks. Yours might look like an acute angle or an obtuse angle. It doesn't matter. I just want you to color the first angle and just color it or highlight it or something with your with the first thing. Yes. For the second angle, it'll be C, B, and D. So angle C, B, and D is colored in green. We do not have any more lines, so we cannot create any more angles, right? On top. What would happen if I put more lines in there? I'm sorry? It will make more angles, right? Yes. So we have angle A, B, and C in blue, which is what kind of angle? Obtuse. Why is it obtuse? It's more than 90 degrees, but less than 180, right? What about angle CBD? Why is it acute? It's less than 90, right? So for that one, as you notice, the letter B stays in the middle. The letter in the middle tells me which one is the vertex. If you notice, B is the vertex for both angle ABC and angle CBD. Keep that in mind. That is very helpful whenever you're looking at the vertex of an angle. Just look at the one in the middle. Well, whenever you have 3 points. All right. So Let me ask you something. Would it be correct for me to say that when you add angle ABC to angle CBD, I will get 180 degrees?
Yes. Just because the whole you're changing it away. Because the whole thing is equal to 100.
What whole thing?
Like the whole line. A to D or D to A, they're all connected to it.
Okay. Okay, that sounds pretty good. Yeah. Any more reasons why you think it should give me 180? Yeah. Go ahead. But I don't have any measurements. How can I add them? How can you subtract if you don't have any numbers? Yep. What does the C do? It divides. That's what I wanted to hear. And good for pointing that out. A, B, C are on a straight line, right? Which creates, ABD, I'm sorry, which creates a 180-degree angle, right? The line D, the point D, when it goes to B, it just makes another, it divides those two. And now you have one part of angle 180 on this side and the other part on this side. But you're not taking away any angles. You're just separating them, right? So because angle ABC, the blue one, and CBD both land on that line, and there's no more angles other than those, then by definition you can say that those angles have to add up to 180 without looking at any other numbers, because we don't have any numbers to judge by. All right, so we're gonna move on. Actually, no, let's just do it now. What do you call that kind of angles? Those kind of angles. Not complementary. Supplementary. We call these supplementary angles. Because it is a pair of angles, two angles, write this down, that add up to 180. There are two angles whose measures, whose degrees add up to 180. I'm not saying one angle, I'm not saying 3 or 4 or 5. I'm talking about two. So I can say that those two angles are supplementary because they add up to 180. And if you forget, I want you to just draw the S. And if you keep going, what does it turn into? 180, right? It's a good way to remember it. Supplementary is an S, and you can turn it into an 8, which reminds you, oh, 180. All right. The next one, right below that one, I want you to draw another line. And you're going to do, now I want you to add another line perpendicular to this line. What does that mean? Vertical, right? Directly vertical to this line. Yes, that's perpendicular. Yes.
Yeah, me too.
Yes, it is. But do it on a second one. Don't do it on the same one. Because I wanted to keep them separate. So, like Faith said, this creates two 90-degree angles, right? Right here on both sides. So this line, just like Dana said a while ago, is actually dividing that 180-degree angles into two. So now you have 90 on one side and 90 on the other, right? I want you to do that, and once you do that, I want you to create a dot in the middle. Use your little string again, and I want you to play with it. You cannot go below here, and you cannot go behind there. You have to stay within the same range right here. And I want you to create another point somewhere wherever you like. and trace it. And by the way, the idea of using the string is to give you an idea of what the angle does. So we're going to use this as A, B, C. A, B, C. And this would be angle C, B, D. We're not worried about it. We're only focusing on one side. Good. It should help you now. So, if the whole line at the bottom is 180, and we're only focusing on half of it, then what are the degrees of this one side? 90 degrees, right? Now, using the same definition as the other one, or the same situation as the other one, what can you say about angle A, B, C, and angle C, B, D? Yep. That when you add them, they equal up to 90, right? Not 180, just 90, because you're talking about the inside of those. Yes. This is what we call complementary angles. These two angles are complementary because they add up to 90. Complementary. I did. Cool like that. Okay. So these are complementary angles because they add up to 90. The other ones were supplementary because they added up to what? 180. But it wasn't at one angle, it wasn't three angles, it was just two angles, right? We're talking about two angles. So you cannot say that ABD is complementary because that's just one angle, right? It's not complementary to anything. Unless angle 0, but that would be kind of crazy. All right. Moving on. Now what we're going to do, we're going to use our protractor to create some of these. What's a protractor? It looks like a semicircle, yes. I don't have one, I'm sorry. And DHD won't buy me any. So I want you to see this. Notice how it expands. However, the degrees stay the same. The directions stay the same. And I'm going to create just one so that you notice what I'm talking about. This is being crazy. So I'm going to draw a line right here. That's horrible. And then I'm going to create a point in the middle, right here. Every time you use a protractor, which I don't know why you guys have never learned how to use it or never were exposed to it, but you go and you place it right in the middle of the point, right there. And let's create a 90-degree angle. Well, let's just create an angle. Right about here. There you go. Now, notice, I'm going to bring this angle right now, right here, to show you another thing. It doesn't matter. Actually, I'm going to let you observe. Tell me what happens when I expand or shrink the angles. Does the measurement of the angle change? If you notice over here where the green thing is, the 30 stays on the same line the entire time. What does that tell me? What does that tell you about angles? The degrees don't change when the lines change, right? So no matter how long the rays go or how short they are, the degrees stay the same. So if you use your finger like that, you have a 90-degree angle, right? You can also use your hands and you can create a 90-degree angle. If you were to stand on a corner of a street that 90-degree angle will still be true all along the streets, right? I need you to understand that. Because some kids think that if I grab this and I expand this line, well, then now the degree should be bigger because it's expanded. And it's not true, right? Yeah, you would think, but there are some kids who believe that the degree that the angles are actually the measurements of the length. Yeah, and they would think that the angles change, and it doesn't. You notice it doesn't matter how big, how long, or short the rays are. The angle is just the distance between them, right? In degrees. So we're gonna use this right here. We're over there, and now we're going to create another one. How many degrees is that? This should fit perfectly in here, and it does. Again, notice that these rays are larger, but they are still 50, and they still add up to 180, even though the rays are larger. Yes. The what? What about it? Well, this is just to show you that they're talking about the degrees. It doesn't matter. I intentionally made it bigger so that you notice that it doesn't matter how big I make it, it's still going to be 50 degrees, and it still should fit in there. And it does, right? So what kind of angles are those? Yes, they are obtuse, but they are supplementary. Why? Yes, there are two angles that add up to 180. Let's make another one over here. Oh, come back. I love this thing. It just bounces everywhere. Make another one right here. And now I'm just going to create a perpendicular line, which will give me a what kind of degree? 190, right? So I'm going to leave that there. And let's bring this over here. How many degrees is that? And 40, right? This should perfectly fit in here, which it does. And that should perfectly fit in here, which it does. I can move it away. Yeah. All right. So tell me, what kind of angles are those? Why are they complementary? Because they equal 90, right? 90 degrees. Good job. This is not the most difficult part. This is the easy part, but I know a lot of you skipped it last year. So no, we're not going to do that yet. The next part is to understand what adjacent and vertical angles are. So on your paper, just draw literally two lines. And write down vertical angles. Intersection. Yes. So vertical angles, they're the ones that whenever you have two lines intersecting, you create angles on each side. They share the same vertex. So in other words, they share the same point. By looking at this, I'm going to name them A, B, C, D. By looking at that, which angles are vertical? Yes. Angles are vertical. D and B? Why are these angles vertical? Yeah, they are exactly the same, and they're also
They'll equal the degree.
uh
No,
no, they're equal. Yeah, they're equal the same degree. They're congruent, but they're also on opposite sides, and they share the same vertex.
wait, did you say like the shapes are like in that these are the same like degree, right?
This is different from what we did before.
No, like, like it looks like this side is bigger than this side, but they would still be the same.
Yes, so that's a good observation. If I were to make this shorter, would it make much of a difference? No. Yes, all of them should be 360, right? But I'm saying it doesn't matter if side B is bigger and side D is smaller. The angle for D and B are still congruent. They're exactly the same, and they are opposites of each other. What would be another vertical angle then? A and C, right? This one and that one. They're exactly the same, and they're congruent, and they're opposites of each other. And the last one is going to be adjacent. Adjacent angles. There are two rules for that one. They have to have the same vertex, and they have to share one line. So if I create an angle right here, which angle, let me erase this to make more sense. Put it on the side. A, B, C, D, E. These are points. If angle A, B, C is one of my angles, what is adjacent to it? It has to have the same vertex, and it has to at least share one side. What? EBD? Well, EBD will be right here, but does it share any of these lines? Which one? He has to share the same point, green, the same green point, but he actually has to share one of those two rays. Yes, A, B, E. ABC is already my angle. So ABE, it will be an adjacent angle because it shares the same point, right? And it also shares one line in the middle. So whenever you're creating these, essentially you want to have this line right here. Well, you just want to have something in the middle between the two angles. And that's pretty much it. CBD, yep, CBD will be another one too because it will share C, it will share the vertex, and you will have D. Are we good? Okay. Yes, hang on. No, you can keep it. I don't know. We did all that. Okay, so on your book, you're going to do page 288. 288 for homework. This one right here. Yeah. No, just this part. 288.